So far in chapter 3, we've done basically everything you can with inequalities. We've got multi-step inequalities, inequalities on both sides, or where there's variables on both sides of inequality. Today we're going to talk about compound inequalities. Before we get into what that is, go ahead and write down a learning target. I can solve and graph compound inequalities, and then do the two warm-up questions. Go ahead and pause the video, hit play when you're ready to move on. So for number 1, to write this says the sum of a negative number and 7 is at most 15. Remember that phrase, at most, means it can't go over 15. It could be 15, but it can't go over. So it's less than or equal to. A negative number, we don't know what that number is, but we know it's negative. So that would be like negative x. So you have negative x plus 7 is less than or equal to 15. When you solve that, notice a couple things happen here. Subtract 7. Now when you subtract 7, you get negative x. So you have to divide by negative 1. Don't forget about that flipping the inequality sign when you multiply or divide by a negative. We've done that so many times now. Describe the solutions to x minus 2 is less than or equal to 9. Well, you would add 2 to both sides and get x is less than or equal to 11. So if we're going to describe that, that's everything that is less than or equal to 11. So that's all real numbers that are less than or equal to 11. All right, so that's just basic warm-up to get you thinking about inequalities there. So that brings us to the question, what are compound inequalities? Well, compound inequalities are when two simple inequalities, in other words, like x is less than or equal to 7, two simple inequalities are combined into one statement with and or. Let's talk about what that looks like in practical terms here. So we've got two things here. We've got 4 examples here of 4 different types of compound inequalities. The first would be like if I said all real numbers greater than 2 and less than 6. Well, if I go, if x is greater than 2, it would look like that. If x is less than 6, it would look like this. So we're saying it has to be this, x has to be greater than 2, and x has to be less than 6. So there's that 2 simple inequalities. Here's one simple inequality, here's the other simple inequalities, joined by this and sign. We can write that as one statement, So I can write that, x is kind of in the middle, right? It's more than 2 and it's less than 6. So x is in between these two values. X is greater than this and less than 6, okay? Think about what that would look like on the number line. We've actually kind of gotten into this a little bit in a previous lesson, one of the word problems. So on the graph, down here is 2, up here is 6, we got 3, 4, 5, 6. Okay, now it's less than, right? So neither on both of these simple inequalities, we're not including the 2 and we're not including the 6. So that would mean we've got open dots at 2 and at 6. Now, x is less than 6, so that would put our arrow going this way, right? But x is also more than 2, so that puts our arrow going this way. So x can't go over 6, so really there is no arrow there. And x can't go under 2, so there is no arrow there. And what we get is a line segment. That joins, that covers all the real numbers between 2 and 6, but not including 6. Okay, here, the second example would be all real numbers greater than or equal to 2 and less than or equal to 6. So same kind of thing before, only now we're including 2 and x is less than or equal to 6. We're including 6. So same thing as before. X is in the middle of these two values. Only now we're including the 2 and we're including the 6. So to get a number line going here, same type of deal. 2, 3, 4, 5, 6. But now, since I'm including 2, we got a closed dot here, closed dot here. And it would be everything in between those two. Same reason. I've got an arrow going to the right for x is greater than 2, but I got an arrow going to the left for x is less than 6. They meet in that center. This is what we call, Let me get rid of this real quick. Oops. Missed it. There we go. This is what we call the intersection, or an intersection. We have values intersecting together to form one set of numbers here. So intersection. Oops. Intersection, not intersecting. Make sure you write that down in your notes. It's important to know. Okay, on the other hand, so notice how all of those had the phrase and. Down here we have the phrase or. Think about how that would be different. So here, this says x is less than 2, all real numbers less than 2, so that would be x is less than 2, or all real numbers greater than 6. This means it's everything except the numbers between 2 and 6. There's no way to write these as one statement because we're not including those two numbers. So let's look at what that looks like on the graph. So we've got a number line here. Again, 2, 3, 4, 5, and 6. We're not including 2 this time, and we're not including 6 because it's just less than or greater than. But this says x is less than 2, right? So that would mean my arrow is going this way for that part of the inequality, and x is greater than 6. So notice how I'm leaving out all this space in the middle here. Okay, so my values are heading everything except the numbers between 2 and 6. Okay, let's take a look at what that looks like with less than or equal to. Same exact thing. So it's all less than or equal to 2 and all greater than or equal to 6. Again, you cannot combine that into one statement. What that would look like on the number line, the same thing as before. 2, 3, 4, 5, 6, number it. But closed dots. Okay, and then x is everything less than or equal to 2, everything more than or equal to 6. These are called unions. Okay, this is called a union. If it says or, it's a union. If it says and, it's an intersection. Notice two different things. If it says or, the values go away from each other. It says and, they go, it includes the numbers between those. All right? Thanksgiving Day, here's our word problem. Let's go through this. Thanksgiving Day is coming up, and you're going to have a feast. Your family needs a turkey that is 20 to 24 pounds. It takes 4 3/4 to 5 1/4 hours to cook your turkey. Write a compound inequality. So you could, if you think about this, you could cook your turkey for 4 3/4 hours, right? So we are including that value. You could also think, could I go less than 4 3/4? Well, if I did that, it wouldn't be cooked. And if I did more than 5 1/4, it would be overcooked. So really what I have here is x, the cook time, right? So let's call that hours of cook time. X is in between 5 3/4 and 5 3/4 and 5 1/4 hours. So here's x hanging out in between these two time values. X has to be more than 4 3/4, but it has to be less than 5 1/4. You go over 5 1/4, you overcook the thing. That's no good either. But it could also be these exact values. So now we're going to graph this on the number line. Okay, so let me change colors here. Let's put 4 3/4 here, or let's put 4, 5, 6. So we can include all those. And we'll split this into fourths. Okay, so 4 1/4 or 4 3/4 is here. 5 1/4 is here. I've got to be over 4 1/4 or 4 3/4 and under 5 1/4. So there's my solutions right there. Okay, so that's what that looks like in the context of real life. That's what a compound inequality would look like. Another example would be like if you are a wrestler and you have to be between, in order to make weight, you have to be between two certain weights or whatever. Or if you're going on a trip, And your bag has to be between two certain weights to be able to go into the storage area, right? Let's talk about what this looks like to solve it. There's two different approaches you could take to solve a compound inequality. We're going to look at the first approach, which kind of breaks things down a little bit more step by step. And then I'm going to show you a slightly faster way in case you want to try that. So the first step is to separate these into two inequalities with the word and. So if I do that, I've got on this one x minus 10, and it says negative 9 is less than x minus 10. And this would be and x minus 10 is less than negative 5. So I've separated that into two separate inequalities. The next step is to solve these separately. Okay, so I'm going to go ahead and do that. To solve this one, I need to add 10 to both sides. And I get negative 1 is less than x. On this one, notice I also add 10 to both sides, and I get x is less than negative 5. So I've got two separate simple inequalities. The next step is to bring the and, quote unquote, down. So to kind of start combining these, I've got negative 1 is less than x, and x is less than negative 5. And then I can actually write that as one inequality here. So negative 1 is less than x is less than negative 5, like that. Now we've solved it. So the next step, we're going to graph each of these inequalities individually, and we're going to do that above the number line. I'll show you why in a second. Okay, go black here, keeping our theme. So here's our number line. We're going to go negative 1. I'm sorry, over here is 5. I just caught my mistake here. Not negative 5. Can't I erase? Okay, so I'm going to go negative 1 to 5. Got that mistake ironed out there. Negative 1, 0, 1, 2, 3, 4, 5. And then we're going to graph each thing individually on the number line. So this says x is greater than negative 1. Notice how these are open dots. So I'm going to put this above the number line, and x is more than negative 1. Then I've got an open dot at 5. And x is less than 5. Notice how this line is going to overlap with that line, right? Well, the last step is to kind of combine this into one graph. And that says wherever there are two lines overlapping, you have an intersection. And we're going to use the dots above as boundaries. So putting this onto the number line, I've got an open dot at negative 1, and I've got a dot at 5. And notice how these two rays overlap with each other, right? Just like we talked about above. So now we can just color in between, making sure we leave those as open dots. That's our intersection. And then we can just delete all of this stuff, okay? Just to clean it up. I mentioned there's a faster way to do this. So let's go back to our original. And this is for when you start to get a little bit better feel for this. You certainly can always break it apart. But my original was negative 9 is less than x minus 10 is less than negative 5. You notice when we solved this thing, on both of these I added 10, right? So rather than break it apart, what I often do is I just go ahead and add 10 here, and here, and here. So you have to add 10 to all parts of the inequality. Because remember, these are two simple inequalities put together. Well, notice over here, we get 1. Okay, and I just caught another mistake I made. Good grief. Time for the weekend. Too bad it's only Tuesday. Over here is 5. Okay, so my mistake was this should have been positive 1. Okay, so that's going to change my graph. because now my open dot goes at 1. Okay, make sure you change that in your notes. Okay. To err is human. Okay, notice here though, I got the same solution as we got before. So you could break it apart into two separate simple inequalities, or you could add that 10 to all three parts. And that's for when you have intersections, okay? Let's go ahead and look, in the next example, we're going to look at a problem that'll be a union, in other words, one that involves or. Okay, so on this one, we have 2 plus r is less than 12, or r plus 5 is greater than 19. We're going to solve each of these individually, just like before. So to solve this first one, we're going to subtract 2 from both. So r is less than 10. Bring the or down. And then subtract 5 from this one. So r is greater than 14. To graph this, we have, let's go 9, 10, 11, 12, 13, 14, 15. See why I did in more numbers here in a second. So r is less than 10. That means it's an open dot, and everything less than 10 is included. Or r could be greater than 14. Open dot that way. When it's a union like this, what that's showing is that the union shows the answers of either inequality. So the variable could either be less than 10 or more than 14. Okay? All right. I want you to go ahead and give this a try on 4 and 5. So go ahead and pause the video, and when you're ready, hit play, and we'll talk about number 4. Okay, so I actually solved number 4 with both methods that we discussed, both the break apart method and solving it all in one place. So if you look over here on the left, see how I subtracted 5, but I did that to all 3 spots. And then when I do that, negative 4 minus 5 is negative 9. And over here, 11 minus 5 is 6. And in the middle, I just have 3n left, because 3n plus 5 minus 5 is just 3n. Then on this one, I got to divide everything by 3. And so I get negative 3 is less than or equal to n, and n is less than 2. There's the and there. Over here, I split it up into negative 4 is less than or equal to 3n plus 5, and 3n plus 5 is less than 11. And I solved each one individually. Notice how I got negative 3 is less than or equal to n, which I could turn around and make that n is greater than or equal to negative 3. That's kind of helpful when we're graphing to have the variable on the left, but you don't have to, obviously. Then to graph it, on the lower extreme, we have n is greater than or equal to negative 3. So that's a closed dot because it's inclusive. It's or equal to. On the right side, we have less than 2. This is an intersection because my ray for the n is less than 2 would go this way. For greater than 3 would go this way. It fills in the spaces in between. Next, let's look at a union problem. Go ahead and pause the video, finish number 5, and then hit resume when you're ready to see if you got it right. Okay, so on here, on the first part, I divided both sides by 7 and got x is greater than or equal to 3. That's plotted down here because it's a closed dot and x is everything more than 3. Or, if I divide this one by 2, x is less than negative 1. That's an open dot with the arrow going to the left. That's going to factor heavily on your homework. Okay, so on this one, number 6 and 7, you should be able to tell right away, are these an intersection or a union? Number 6, we've got a union. So that would be the word or, right? Number 7 would be the word and. So on number 6, let's write that there. This is or, this is and. So on 6, on the left side, we have x is less than or equal to, because it's a closed dot, right? Negative 3. On the right side, so we got to put or in between. Or x is, notice that's a closed dot, greater than or equal to 2. And it's as simple as that. You've done this like writing inequalities with simple inequalities, very similar here. Now we're going to use and here, and there's going to be 2 steps for this one because we're going to write the 2 simple inequalities, then we're going to combine it into one compound inequality. Notice how these are open dots, so no lines underneath the inequality sign. So here, take the one on the left, x is greater than -9, and on the right, x is less than, so and x is less than -2. Okay, so notice how x is bigger than -9, so -9 is the low end, -2 is the high end, and x is in the middle. X is less than -2, more than -9. So it's going to end up going like that. Okay, one more. Let's look at a word problem here. A book club has between 15 to 20 members inclusively. Well, what would that word inclusively mean? Well, inclusive means including, right? So they would include 15 members. They'd be okay with 15. They'd be okay with 20. Okay? That means inclusive would mean a closed dot. Okay? So that word inclusively is pretty important. Okay? So this says graph the number of members. So write in compound inequality. So x is the number of members. Number of members. Okay? X is the number of members. X could be greater than or equal to 15, right? So 15 is the lowest amount, but we're including 15. And x is less than or equal to 20. Because it could be both of those things. It's not like we either have less than this or more than this, but we will not have between 15 and 20. That's not what it's saying, right? If it were or, it would be saying, well, we don't want between 15 and 20. We would not have more than 20 or less than 15. But it's just saying we could have between 15 and 20. This is an and question. So now we need to graph that. Let's put this together. So x is in the middle. 15 is our low amount. 20 is our high amount. X is more than or equal to 20, or 15, it's less than or equal to 20. So on the number line, 15, 16, 17, 18, 19, 20. We got closed dots at 15, and we got a closed dot at 20. Make sure those look closed. This part would go this way, right? That ray would come from the left to the right, and this would come from the right to the left, meeting in the center. So there we go. Okay, that's it. Go ahead and try your homework. Make sure you, and then you got your practice test. Make sure you schedule a time to take your Chapter 3 test and your Chapter 4 pre-test.